keywords from some previous testers from Davis language testing dictionary and ITP ATP guideline. ITP stands for International Testing Institution, or ITC, ATP, Association of Test Publishers. So communicative test is about test of communicative skills. Like now I'm doing a presentation, and they are direct assessments. They are not indirect. So they prompt learners to use the language in sort of a simulated context, and which involve authenticity of the materials being used in simulation of real-life language use situations. And the constructive responses, unconstrained, and they're open-ended. So you don't know, you cannot predict what learners are actually going to say. And so it involves phrase production of spoken and written texts. So what are some benefits? I can go through that quickly. Automated scoring leads to efficiency of testing, thinking about the logistic complexities of training raters, sort of calibrating raters, and also adjusting scores, etc. And also automated scoring leads to scoring consistency, because we are aware of the inconsistency among raters. Sometimes through calibration, we try to minimize that. And definitely cost reduction. I don't want to talk too much about that. And mitigation of examiner shortages, because we know that in certain contexts, we don't have enough qualified examiners. So the speaking test or writing test have to go with limited portion. And it's very difficult to book test places. So by using automated scoring, we can actually allow on-demand testing. And so test takers can take the test from anywhere in the world, anytime in the world, 24/7. And Carol Chapelle and Yuri Chun talked about the potential of using automated scoring systems to provide feedback for learning. So if you look at the 2010 publication learning testing, they talk about the promises of using NLP technologies to provide feedback. And I will leave this topic to Xiaolu and Guoxing in the next session, because I'm going to focus on automated scoring only, because the extensive topic is about automated feedback, which I'm not going to touch upon in this talk. Xiaoming Shi and actually had some overview of stakeholder perception of automated scoring. Actually, there are different stances from different disciplines. From computational linguistics and educational measurement, researchers are sort of embracing automated scoring, thinking about it as a new thing, good things to have. And they are very optimistic about that. You know, the latest standards of educational and psychological measurement is specific sort of guidelines on how to incorporate automated scoring into testing practice. What kind of evidence needs to be provided? I'm going to unfold that a little bit later. But from language teachers' perspective, there's a lot of they're very skeptical about using automated scoring, because teachers don't know how automated scoring system work, because the language construct is so complicated. And to be honest, Carol Chapelle was talking about the difficulty of defining a construct, right? So that's why construct validity is so elusive concept. And even if people and examiners cannot unfold the construct of language sufficiency, how can a computer do the work? So people are always suspicious about a computer's job is equivalent to the teacher's judgment. But language testers actually is a mixed of views. Xiaoming described language testers' views as cautious optimism. So optimism is like they're leading to more efficient test taking, also leading to feedback, leading to sort of more consistent scoring, but also there are worries about the negative impact of using automated scoring on test design, because we often see a narrow construct, a non-communicative test design, etc., which is not good, not favorable to a lot of old school language testers. And also from test takers, I think Jing Xu and also Xiaoming Shi and her team did some sort of surveys and with test takers on using automated scoring system on PT academic and also on TOEFL speech rater. So the test takers seems to be not quite confident in the automated scores given by the computer. They prefer human scoring over automated scoring. So this is the overall scenario of people's perceptions about automated scoring right now. Now I'm going to jump into some technical details. Hopefully, I will dumb down the language a little bit so everybody can understand. I think to help people believing on this scoring, we have to educate them about how those scoring systems work. So this is an example of a text auto marker. This is architecture of a text auto marker from receiving the text to parsing the text to extract features from the text to predict scores. And then the features will be thrown into a scoring model, which will actually predict the final score and how it works. So this is an example. I'm going to use an analogy here because I think it's like a cooking food, right? You need different ingredients, and you're going to pick different things from different shelves, and it's the same thing for the text auto marker. So when you receive the text, for example, there's a sentence, then a thought occurred to me. The sentence detector will first set a boundary of the sentence. So the yellow words like a sentence in brackets. So the front of the beginning of the sentence and the end of the sentence. And then tokenizer, the next step is for the tokenizer to turn the sentence into different words. The following that will be part of speech tagging. So giving a part of speech tag to each individual word. For example, then is an adverb, A is an article, and thought is a noun phrase. Occurred is a verb in past tense to the preposition, and me is the pronoun. The next step is lemmatization. So lemmatization is basically a morphological analysis of each word, turning the word into its base form, original form. So for occurred will be turned into occurred, better will be turned into good, etc. This will help the scoring system to recognize the unique words in the text. So how many unique words you use in your writing and speaking. So the parser will actually do the syntactic analysis. I'm going to show you a parse tree very quickly. It just will tell you the general syntax of a sentence. What are some? It's more like a disintegration of the sentence into different small segments and the relationships between each part of the sentence. The final bit is a parse ranker because actually a parser will provide several solutions. So there are different probabilities with each solution based on the corpus. The parse ranker will actually rank each parsing solution and tell you what is the most likely one. So this is an example of a parse tree. So for example, then a thought occurred to me started with an adverbial phrase, then a sentence consisting of noun phrase and the verb phrase, and then noun phrase will be decomposed into article and a noun, and the verb phrase will be decomposed into occur in past tense and prepositional phrase to me. So preposition plus a pronoun. So these are the parsing. The parsing provided the ingredients for the scoring model, right? The scoring model picks the necessary information, different features to predict the score. So here are a list of possible scoring determining features. So these are the generic auto marker. I'm not naming any particular auto marker from any of the testing organizations. These are possible features that are actually used in the scoring model. So anagrams are actually word sequences like bigram to choose adjacent words to consecutive words, trigram, 3 consecutive words. So this is slightly different from corpus linguist approach to detect formulaic sequences, because formulaic sequences can be like collocation, does not have to be next to each other, like throw a party or blow a horn, etc. It can be separate, but anagrams is like consecutive words. So this is a different approach from computational linguistics than the corpus linguistics. You can see that we are approaching the construct from different perspectives. And also concept detected misspellings and unknown words, concept errors. Some of the corpus used to train the auto marker are error annotated. So the auto marker may be able to detect different types of errors in writing or speaking. Average sentence length, concept special words and phrases. This particular feature concerns formulaic sequences. So as soon as in that, so the particular fixed expressions that the auto marker will be looking for in the writing or speaking to predict learner's proficiency. In this aspect, it's consistent with human examiner's judgment, because human examiners will be looking for those expressions, very native-like expressions to make a judgment of proficiency. And past rule names like different passive voice, relative clause, etc., and grammatical relation types, so passive voice, etc. A number of these clause markers are sort of proxies for the coherence in writing. So this just give you a sort of rough idea about what the auto marker is looking for in the response. And also there are possible topic relevance and content features. This is more technical. So to explain that, I need to explain what is a vector is. So if you learn matrix algebra, so there'll be rows and columns. A row is a row vector, column can be a column vector. So thinking about space, like what on GPS, you have to, and one parameter is the direction, the other parameter is the distance, right? So it's a two-dimensional matrix. You find all TEASIG values based on whom is direction, distance and direction. And then you can throw in one more dimension, time. So right now in British Council on this day at what time, there's another dimension, another parameter. So you think it's a multi-dimensional sort of matrix which capture all the meaning in sentences, like people, audience, time, what's going on, who's presenting, etc. So this will be thrown into a multi-dimensional vector. And this will be extracting information from the response and from the prompt. So the idea about topic relevance is to compare the particular point in the multi-dimensional semantic space in the prompt versus in the response. How close are they? Right. And the second bullet is about similarity of essays on the same prompt in background calls. This is easier to understand because you're looking for similarities on good essays on topic. What are some similar things extracting the information? And also prompt-specific vocabulary use, which is used in E-Rater from Unwright and Quinlan's publication. This is easy to understand as well. And the more latest use of prompt relevance is about using latent semantic analysis. This is more complicated to explain, but usually in this particular approach, you have a large collection of responses was written on the topic, which is on top, high rating on the topic, and you're looking for try to build a semantic space or topic space, which has a general feature about this particular responses to this particular topic. And the auto marker's job is to compare a particular response, a new response, to the generalized feature in the semantic space. How close is the new response to a collection of responses, and to see how similar they are. The last bullet is about vector proximity between sentence and paragraphs. The same idea applied to two adjacent sentences, like how close is the information carried in sentence 1 compared to sentence 2. So how close are they? So this is an indication of coherence in writing. So it can be from between paragraphs, can be between sentences. All right, so hopefully you get it. Okay, so now we talk about speaking, which is easier to explain. So speaking auto marking, just you need to add one more component, which is independent of text parsing, is ASR, or automated speech recognition. So this component is about transcribing learner's speech into text. So I'm not going to unfold the idea of language model and acoustic model. You can read the citation here, which will explain more in detail. But the idea is that transcribing learner language is error-prone, especially learner language is accented. So you can see the figure here. The more proficient you are, the less likely the ASR going to be erroneous. So usually, high-level speaker is going to speak clearly, fluently, native-likely. So it'll be easier job for the speech recognizer to transcribe the speech. But for low-level speakers, their speech is going to be disfluent, accented, and there'll be more error in their speech. So here are some scoring features for speech auto markers, and they can be aligned to different constructs like pronunciation, vocabulary, grammar. But you can tell that these are all proxies. It's different from human judgment, right? So pronunciation of the phonemes that are parts of the words, percentage of phonemes that were correctly pronounced, and the median of how confidently a word could be transcribed can be recognized by ASR. Okay. And also vocabulary unicorn diagram, and it's quite similar to the speech, to the text auto marker. So I'm not going to go into details right now, but it's the same idea. The only difference is that there's an ASR component, which will introduce errors into the text. All right, now I'm going to jump into practical issues in auto marker training. The one big issue is data shortage, and usually we don't find enough responses at the edges of the score scale, the top extreme and the bottom extreme. So you can see this figure that this is from the paper in 2010 that Brasco actually trained the auto marker with data set from different years with a different volume of data. The point, the number of the correlation between human score and auto marker score. You can see the larger volume of data is the higher the correlation is, right? This is intuitive. And the second point is about the quality of human marking, because we have to train the auto marker with the human annotated responses. But human marking, the consistency is always the issue. And in the recent paper published by me and my colleagues, we found that the markers actually are diverse in their severity in marking scripts, even though they are professionally trained examiners. They are different. And the ITC and ATP guidelines that when you train or evaluate an auto marker, you have to use double mark, at least a double marked responses. But you know, we're going to revisit this issue later. These cause problems. And then scoring model selection is another question we need to consider in auto marker training. So there can be prompt agnostic models, so the auto marker can mark all the topics, or prompt specific models, in which the auto marker only mark particular prompts. So there are both pros and cons. I will just focus on the training data here. So it usually takes more training data to train and prompt agnostic model. It's only a generic model which can work on different prompts. The problem is that usually you need to add in content relevant features into the prompt agnostic model. In contrast, prompt specific models are trained on particular responses. The downside is that you have to prepare data on that prompt. For each new prompt, there will be a new model, new scoring model. So it's very logistically complex and costly to develop auto marker for different prompts and to validate auto marker for each prompt. I think the industry standard is that now we are more leaning toward the prompt agnostic models, but also prompt agnostic model is less sensitive to topic relevance and content relevance as compared to prompt specific models. I think in the general consensus that for large scale testing, it's more realistic to develop prompt generic or prompt agnostic models. But for learning context, the prompt specific models will be more useful because there's no risk of item exposure. So the topics prompts can be reused indefinitely. Oh, the other thing is about validity, because for prompt specific models, you can say that for each particular prompt, there are different scoring model. In other words, you're applying different set of criteria to assess different prompts. That causes a problem for interpret the construct, right? So the construct interpretation is based on consistent scores. The scores are not consistent, then how can you interpret the construct? So each construct associated with each prompt is different. It'll be hard to justify for large-scale testing. And also for auto marker training, we have to consider different scoring models. The typical scoring model including regression, classification, preference ranking, and then now more people are using neural network models. The downside of neural network models is that it's very difficult to interpret because there's a lot of embeddings of sort of prediction models. So one embedded in another one. So it's impossible to interpret those models confidently. But it's easier to reconfigure for auto marker training improvement. Usually the neural network model is worse at the scoring extremes, but better in the middle. Okay, and the big problem that the test developers encounter is that the unusual responses. This include like shift of test taker behaviors, which is different from the training data, and also test takers with disabilities the automark has never seen, like impaired speech, like people stammer when taking a speaking test. This will cause problems. I think these people will need to be marked by human raters. And also creative responses. So people may say, oh, when you talk about sports, I'm not really a sports person, but I recently attended a parade. So you switch the topic. The automarker would say, okay, this is off topic, definitely. But human raters will be more sympathetic. Okay, this is something you never heard about, and we'll still give a higher score. And also strand responses due to technical problems, due to audio quality, or internet drops, and so there's unfinished responses and the gaming behavior malpractice. So recently, Xiaoming did a research on test takers' behaviors, anticipated behaviors. They know that the speaking test is marked by a computer. So the test takers say that they will speak as quickly as possible and try harder to pronounce words clearly, and keep speaking even if they don't make any sense. So these are something really bad things washed back on the learners. And they may employ strategies to trick the computer. And also, we know that there's a lack of features to manage high-order language skills. And Xiaoming, I think she was proposing a new special issue in Lambda something quarterly, I think. She was soliciting research into new innovative features to capture the high-order construct like turn-taking, conversation, contextual appropriateness in language, and collocation use in speaking right, mediation, nonverbal communication. These are constructs that have been left behind by the automated scoring algorithms. Okay, I'm gonna quickly talk about some issues in automatic evaluation. Because a lot of evaluation statistics, people report is a single number, like percentage agreement, correlation, kappa, Rubin square error, standardized mean difference. Just give you a single number from 0 to 1. But what does that mean? We don't have any clue. So actually in the recent paper, we argued that correlation is a measure of association, not agreement. It's not appropriate, and a kappa is hard to interpret and can behave strangely. And few people know that kappa can be negative. And if you read our paper recently, we give an example how kappa can behave counterintuitively. And we propose limits of agreement in our recent research on automatic evaluation. So in this chart, you can tell that 95% of computer-human differences lie between -7.5 to 0.75 to 1.57 CEF1 band. So basically, you sort of detailized the difference on the score scale. So give the test users an idea about deviation, the differences between automarker score and the human score on the score scale per se. This is much better than the arbitrary number from 0 to 1. And also, you can tell that automarker may behave differently at different score band. For example, you can tell that if the automarker score is roughly in the middle of the B1 range, then the mean difference between human score and automarker score can be 0.4. So automarker tends to be perform more accurately around B1-ish because the difference is quite small. But on the two extremes, the pictures may be very different. So we will need test developers to show us this information, not a single number, right? And another thing we don't see a lot is about bias analysis. This is a standard. This is the guideline from the Standards of Educational Psychological Testing, which would encourage test developers to provide information about some potential systematic bias of the automarker on some subgroups of learners. And we don't see that a lot in the literature. But we know that automarker is trained on several key groups, key test taker groups in the candidature. So it cannot cover all the test population. So the auto marker must be biased to some extent, right? Toward the key stakeholders in the training data. But we don't know how biased the auto marker is against those test takers not in the training data. And we need this information from the test developer. Okay, I think there's a time limit. I'm going to skip that, but in the recent consumption that we revealed the limitation of the auto marker. In this way, we can actually try to escalate the responses that auto marker cannot mark or do not feel confident in marking to human examiners. But for example, we can use language quality score to predict the difference between auto marker score and human score. This is the recent publication where we use the ASR confidence score to predict auto marker deviation from the human score, which is very useful and successful. But there's a double standard conundrum because the auto marker is trained on double marked responses, which is statistically adjusted and can be fair average from the rush analysis. So auto marker training, the data is fine-grained, it's gold standard data. But if we escalate the response to a human examiner, the human examiner will be a single marking in most cases. So human marking and the auto marker may be on two different standards, and we will interpret the scores in the same way. That caused the problem. Okay. And then there are ethical issues in automated scoring, like task design constrained by AI technology. We see that a lot. I'm not going to unfold that. And interpreting the neural network models, we cannot do that. And do human score, the machine score have the same meaning? It's always, this is I think an everlasting problem because we approach the same issue from different perspectives. But we are putting the same score align the same score with the same band descriptors. In test interpretation, we use the same interpretation, but actually the scoring process is different. But some people may argue that human raters, actually, their scoring process is different as well. I don't have an answer to that. And wash back on test taking and transparency, regulation, and quality assurance. And this is an issue for regulators because regulators is not pushing test developers to sort of publish information about auto marker performance special limitations. And I think different regulators from different regions have different standards. And the test developers are not getting enough pressure either from the regulator or test users to open the door to be more transparent. So I would encourage test users to ask the right questions. But before that, the premise is that we need to promote AI literacy among stakeholders so that they can ask the right questions. So here are some questions that we mentioned in a recent publication led by Nahal from Krella, and like what data the auto marker is being trained on. So is your candidate's data sort of similar to the training data used by the auto marker? And how the test administered in practice? Is there any background noise, cheating, potential cheating, which will affect auto markers' judgment? And what tasks are being used? Is that non-communicative task, which is constrained by technology? How similar the task in the test will emulate the target language use situations, etc. And what scoring features, which is for construct coverage, what scoring features are being used by the auto marker? We need to see a clear alignment between scoring features and the construct of the test, right? So all the constructs should be covered by different proxies or scoring features used by the auto marker. And the potential impact on learning. So we don't really want test takers to give very minimal responses to trick the system, because communicative competence is not like that. We don't want people to have a misconception that language proficiency is like what constrained speaking tasks or writing tasks look like. And then finally, the good fit between the purpose of the test and the test used. Okay, concluding remarks. I think there's a lot of work needs to be done, and the literature, the research on automated scoring is still in its infancy. And Xiaobing mentioned there's a lot of room for the validation work on automated scoring to grow and expand, mature. And hopefully I'll be part of that. So I will follow their footsteps, try to expand that. And I think the test developers and the users share their responsibilities to validating automated lemma tests in specific assessment context. This is a quote from Messick, but I tweaked it a little bit. So I think the stakeholders need to show the responsibility to validating particular use of the automated testing in their own context. But before that, they need to be quickly empowered by AI literacy. Oh, that's the end of my talk. So the citations in the references, one is the chapter in a edited volume. The other one is our recent publication in Fumi and Vivian's special issue, which talk about using confidence scores to predict automarker inaccuracy. I think that this is quite cutting edge. I don't see a lot of automarkers that use confidence measures to say, okay, these responses need to be remarked by human. So this is the innovative bit, which makes it interesting. All right.